All right, your quiz on Thursday is over section 717273. God bless you. I put a quiz review up, God bless you. That is due, I think I have it due for tomorrow morning, but it's not worth any points. There's no submission. Like if you don't do it, you don't have to. But I'm just providing you with some more review material. So tomorrow when you guys come in, just say, hey, can you go over this one? I don't know how to do this one, that sort of a thing. Because tomorrow's an early release. So I just want to touch base with you guys and see if you have any questions about anything. But second part of 7.3 is called partial fraction decomposition. It sounds a lot scarier than it is. If something decomposes, it breaks down. Yes? So all we're going to be doing is taking a big rational function and breaking it down. If you look at this first slide, x plus 14 over x minus 4x plus 2, when you partially decompose it, it breaks down into 3 over x plus 4 plus negative 2 over x plus 2. If you were to combine those two, if you were to add those two back together, you would get x plus 14 over x minus 4x plus 2. All right? We're going to be going backwards. We're pulling it apart. And I'll show you exactly how to do that. All right? This is the example that they give you. We are going to use linear factors. We're just, like I said, we're going to break apart. If you notice, look at this bottom here. How many different factors are in the denominator? In the bottom. 2x minus 1 is a factor, x plus 2, and x minus 2. So there's 3. So do you see how they broke it apart into 3 pieces? All right, if you had 5 things in the denominator, you break it down into 5 pieces. And I'll show you the algebra behind it right now. This is in words how you do it. You're going to first always factor the denominator. Then we're going to split each term into a denominator. And you're going to assign A, B, C, D, however many you have. And then we're going to find a common denominator and solve. I'll show you. It's super easy. All right, find the partial fraction decomposition. First of all, you factor the denominator. Is the denominator factored? All right, so the denominator is already fully factored, right? How many factors are in the denominator here? 2. So we're going to say, okay, this is equal to x minus 3 plus x plus 5. Now you could put x plus 5 first and x minus 3, doesn't matter. And then you assign a letter to the numerator. So this is going to be A and this is going to be B. Everybody with me on that? All we did was just break it apart. You factor the denominator and break it apart. Now if I was going to combine these back together, I would have to have a common denominator, correct? So if I look at fraction A over x minus 3, if I was going to bring them back together, what would a common denominator be between x minus 3 and x plus 5? Right, you got to put them back together. So this one has the x minus 3. What's it missing? The x plus 5, correct? Yeah. Your second fraction has the x plus 5. What's it missing? X minus 3. The x minus 3. Everybody okay? Yes? All right, so now we're just going to take just the top. And we're going to solve that. You have 6x plus 14 equals A times x plus 5 plus B times x minus 3. Now we're going to solve this equation twice, and we're going to use 2 x values. And the x values you use come from the denominator. So what are the 2 x values in the denominator? If I set each parenthesis equal to 0, I get x equals 3 and x equals negative 5, right? So we're going to solve this twice. First, I'm going to use x equals 3, and here I'm going to use x equals negative 5. This is the same process you guys would use every single time. And the same thing will happen every single time. So watch, on the left-hand side, we're going to solve using x equals 3. So instead of x, I'm going to put 3 plus 14 equals A times 3 plus 5 plus B times 3 minus 3. You guys see that? Okay, so let's simplify. What's 6 times 3?
18.
So 18 plus 14 equals, what's 3 plus 5? 8. So 8a. You guys agree?
Yeah.
And then what happens with 3 minus 3?
0.
0. So this would cancel out. What's 18 plus 14? 32
Yeah.
equals 8a. And then do what?
Divide.
Divide both sides by 8.
A equals 4.
So a equals 4. You okay? All right, now we're going to do the same thing on the other side, but instead of using x equals 3, what are we going to use?
-5.
Okay, so 6 times -5 plus 14 equals a times -5 plus 5 plus b times -5 minus 3. So when we simplify, what is 6 times -5? -30 plus 14 equals, what's -5 plus 5?
0.
Times a, so that just cancels out. And then what's -5 minus 3?
B -8.
So this would be -8b. You guys agree? All right, so simplify a little more. What's -30 plus 14?
-16.
-16 equals -8b. Now what?
Divide -8.
Divide both sides by -8, and b equals 2. Now to write your partial fraction decomposition, we go back up here. And we fill in our a and our b. So you would have a is what? 4. So 4 over x minus 3 plus 2 over x plus 5. And that's it. That's your partial fraction decomposition. Now, in order to check, right, if you were going to check to see if you did this right, if you were going to get a common denominator between x minus 3 and x minus 5, you would just put them together, right? Or x plus 5, I'm sorry, correct? So you look, your first fraction 4 has the x minus 3, it's missing the x plus 5, right? So you would say x plus 5 here. Plus, the second fraction has the x plus 5, it's missing the x minus 3, correct? So if you distribute this, I have 4x plus 20, right? Plus 2x minus 6. What's 4x plus 2x?
6x.
6x. What's 20 minus 6?
15.
Is that what we started off with over here?
Yep.
Then you're right. You will do that the same way every single time. And when you, if you want to check, you just cross multiply. Like just take the denominator of one, multiply it to the other.
That's positive 20, right?
Mm-hmm.
Oh, okay. I almost thought it was negative for a second.
Okay, same thing. This one's already factored for us. So how many different fractions am I going to write? There's 2. I have x minus 2 and I have x minus 5, correct? Okay. So I'm going to say this one is A, this one is B. So now, A fraction has the x minus 2. It's missing the x minus 5. B has the x minus 5. It's missing the x minus 2. Everybody agree? Okay, so I'm just going to rewrite my top statement. X minus 14 equals A times x minus 5 plus B times x minus 2. Now, where do I get my x values that I'm going to use to plug in?
From the equation, denominator.
From your denominator. What are my 2 x values I'm going to use?
2 and 5.
X equals 2 and x equals 5. You set the denominators equal to 0. So here I'm going to use 2. Here I'm going to use 5. So 2 minus 14 equals A times 2 minus 5 plus B times 2 minus 2. What's 2 minus 14?
Negative 12.
Negative 12, okay. And then what's 2 minus 3? Sorry, 2 minus 5. Negative 3A. And then what happens with 2 minus 2? It crosses off.
Will it always like
Yep.
have it where one crosses off?
One will always cross off. Good. Divide by negative 3, so A equals what? 4. I was just about to ask that. Every single time, guys, one of your, you should only have one variable left. If you have 3, then 2 of them should cross out. So here, I'm going to start off with 5. So 5 minus 14 equals A times 5 minus 5 plus B times 5 minus 2. What's 5 minus 14?
Negative.
Negative 9 equals, what happens with 5 minus 5?
Cancel out.
Cancels. And then 5 minus 2 is 3, so 3b.
Yep.
Divide both sides by 3. What does b equal?
Negative 3.
Negative 3. Good. So now we go back to our original where we broke it up. My first fraction was x minus 2. My second fraction was x minus 5. What was the value I found for A? 4. And what was the value I found for B?
Negative 3.
-3. You can write it like that, or I could change the sign in the middle to a what?
Negative.
A minus sign. And then to check it, you just multiply 4 times x minus 5 and negative 3 times x minus 2. But there is your partial fraction decomposition. Okay, we have some extra ones here. Look, this says write the form of partial fraction decomposition, but don't solve it. If you want to go ahead and solve it, that's fine. You don't have to, though. We're just working on breaking it. What's wrong here? What do I have to do first? I have to factor the denominator. So what would my denominator factor into?
1 and 9.
Okay, x plus 1 and x plus 9. You guys agree? Okay, so if all we're doing is setting this up, we would set this up as the first fraction's x plus 1, the second fraction x plus 9, correct? I have an A and a B. All right, that's all they're asking you to do here is just set it up. If you were going to go ahead and solve, what would the two values be that you used to solve with x?
Negative.
Good, x equals -1 and x equals -9. And if you were going to go ahead to solve, you would multiply A by what?
By negative.
X plus 9, and then you would multiply B by what? X plus 1, and then just go ahead and go in. All right, but all they're asking you to do here is just set it up. So the setup part, the orange or yellow, whatever color that is, A over x plus 1 plus B over x plus 9.
So that's it?
Yeah, for that one. On your web assignment, there's only one question like this, and it's just setting it up, and I'll show you. There's an example of it, but you guys are going to have to, it looks like this. All right, when you have repeated, do you see how this is the same thing repeated 3 times?
Yeah.
So you're going to have, there's really 3 here, right? It's x plus 1, and x plus 1, correct? When you have 3 or 4 or 7 of the same denominator, same binomial, the way that you write it is each one to a different power. So the first one, you're going to write to the first power. Your next setup would be x plus 1 squared, yep. And then this would be x plus 1 cubed. If you had it to the 4th power, you'd have 4 denominators, and it would be first power, second power, third power, 4th power. But mathematically, that's how it works out. If you just write x plus 1, x plus 1, x plus 1, it doesn't mathematically work. And then your denominators would be A, B, and C. We're not going to give you any that you have to solve like that.
So you just have to set it up? If we
Yeah,
do?
just have to set it up. See how it says, do not solve? Just set it up. Same thing here. Do not solve. We're just setting it up. So what would your denominators look like? How many of them do you have?
3.
You got 3, right? So I'd have x minus 1, agreed? And then I'd have what?
X minus 2 to the first and then x minus 2 squared.
Good, yep. And this would be A, B, and C. Again, you're not solving those. Whenever you have something that's raised to a power other than 1, you write it out to the first power, then to the second, whatever it goes to. If it goes to the 8th, you'd have first, second, third, fourth, fifth, sixth, seventh, eighth. Does that make sense? Okay, any more on this one? Okay, let's go back and solve. This one's a little longer, but you don't do anything any different. How are you supposed to solve this? What is the first thing we do? Factor. So this becomes x times x squared minus 4, correct? Which becomes what? X times x plus 2x minus 2?
Yeah.
Okay. So how many different fractions are we going to have here? 3. So I have x. I have x plus 2 and x minus 2, right? So we have an A, a B, and a C. Same exact process. It just takes a little bit longer. So the first fraction has the x. What are the 2 things that it's missing?
The x plus 2 and x minus
X plus 2 and x minus 2. Your second fraction has the x plus 2. What are the two things that it's missing?
X and the X minus
X, the x minus 2. Good. And then C has x minus 2. It's missing
X and X plus 2.
x and x plus 2. Perfect.
Would you just combine those, or you don't combine them?
You don't have to. I mean, you can if you want to, or you can just leave them because you're just going to algebraically work it out. So it doesn't matter.
Okay.
So now I'm going to set up my problem, and it's going to say x squared plus 12x plus 12 equals a times, like Camilo said, you can go ahead and multiply that out if you want to. Be x squared minus 4, right? Plus b, and then this would be what? X squared minus 2x? You don't have to if you don't want to. And then c would be x squared plus 2x, correct? Now again, you don't have to. You can if you want to, but you can leave it in its factored form. So now I'm going to have 3 values that I have to plug in for x. What are my 3 values going to be?
0.
X equals 0, good.
X minus 2.
Negative 2 and
Positive.
positive 2. So we're going to do this again.
But you just have to put the previous.
Yep, you got to do 3 of them. So over here I'm going to do with x minus 0. So 0 squared plus 12 times 0. I didn't give enough room. Plus 12 equals a times 0 squared minus 4 plus b times 0 squared minus 2 times 0, right? Plus c times 0 squared plus 2 times 0. So 0 squared is 0. 12 times 0 is 0. Then I have 12 equals. What's 0 squared minus 4?
Negative 4.
Negative 4a. What happens with 0 squared minus 2 times 0?
It cancels out.
It cancels. What happens with 0 squared plus 2 times 0?
It also cancels.
It cancels. So a equals what here, guys?
Negative 3.
A equals negative 3. Good. It's a lot to write out for that first step. But like Camilo just noticed, you'll always have just one variable left. Everything else, if you have 8 variables, 7 of them will cancel out. So now I'm going to evaluate this, but I'm going to use x equals negative 2. So it's negative 2 squared plus 12 times negative 2 plus 12, right? Equals a times negative 2 squared minus 4 plus b times negative 2 squared minus 2 times negative 2 plus c is negative 2 squared plus 2 times negative 2. So on the left-hand side here, negative 2 squared is 4, right? 12 and negative 2 is minus 24 plus 12. So 4 minus 24 is negative 20 plus 12 is negative 8. All right, now let's simplify up here. What is negative 2 squared? 4, and 4 minus 4 is 0. Second parenthesis. Negative 2 squared, 4. Minus 2 times negative 2, so that's plus 4, right? So that gives me positive 8, so 8b. And then I have negative 2 squared, which is minus 2 times 2.
0.
Yep, that cancels out. So what does b equal, guys?
Negative 1.
Negative 1, yep. Again, it's a lot to write on in that first step, and then whole lots of zeros. So now we're going to do it again. And we're going to plug in positive 2. So come over here, x equals 2. So I had, what was it? All right, so 2 squared plus 12 times 2 plus 12 equals a times 2 squared minus 4. Thank you. Plus b, and then it's 2 squared minus 2 times 2. And then we have c 2 squared plus 2 times 2? Okay. So 2 squared here is 4 plus 24 plus 12. What's 4 plus 24? 28 plus 12 is 40. All right, 2 squared is 4, and 4 minus 4 is 0. 2 squared is 4, and 4 minus 4 is 0. 2 squared is 4, and 2 times 2 is 4. So I'm left with 8c. You guys with me? Divide both sides by 8, and c equals 5. So now we go back to the beginning. I have my a value, my b value, and my c value. So I would write a is negative 3 over x. Now I can say plus a negative, or I can say minus. It doesn't matter. I'm going to write minus 1 over x plus 2. And then I have plus 5 over x minus 2. And there's your partial fraction decomposition. That is a very long problem. One thing I do want to bring to your attention. Let's just say I had a equaled 3 over 2, right? Say I had this fraction a, and then it's x minus 6. Okay? You guys follow along? I solved it, whatever, some arbitrary problem. And I came out with a equals 3 over 2. This is not the correct way to write that. How do you think I would write if a was 3 over 2? Where would I write the 3 and where would I write the 2? Yeah, 2 would be in the denominator. You would write it as 3 over 2 times x minus 6. If you get a fractional answer for one of your a's, your b's, your c's, whatever, just put the numerator in the top and put the denominator in front of the parenthesis on the bottom. Does that make sense? Yeah. Okay, that's it.